Hi guys, welcome to the today's session of design and analysis of algorithms. In this session, we are going to see one more application of brute force technique, which is nothing but brute exhaustive search. Now, exhaustive search is a brute force approach that allows exploring every possible combination from a set of choices. Every problem may have a set of choices. So it explores every possible combination from that set of choices. A brute force solution to a problem involving search for an element with a special property, usually among combinational objects such as permutations, combinations, or a subset of a given set. Now, what the basic steps involved in brute force exhaustive searching? Now, first we need to generate the candidate. Generate the candidates. We need to evaluate the candidates, select the best, repeat or terminate the procedure. Now, what about these basic steps of exhaustive searching? First, generate the candidates. So here, enumerate all possible candidate solutions to the problem. Enumerate all possible candidate solutions. That is, find all possible candidate solutions to the problem. These candidates could be combinations or permutations or selections from a given set. After enumerating, we go for evaluating the candidates, which is the second step. Calculate the objective function or criteria for each candidate solution. This could involve determining the solution's quality or fitness based on the problem's requirements, whether it is satisfying the given objective function or not. After checking the quality or fitness of our choice or candidate solution, we need to select the best solution. Compare the evaluated candidates and select the ones that meet the problem's criteria or constraints. Depending on the problem, this might involve finding the minimum or maximum or most suitable solution. For some problems, it may be minimum. For some problems, it may be maximum. And for some problems, it might be a most suitable solution. And finally, repeat or terminate. If the solution is not found or the search space is not exhausted, return to the step 1 and continue to search. Otherwise, terminate the search and report the selected solution as the final solution. Now we will see some of the examples which can be solved using exhaustive searching. The first example is traveling salesperson problem. You are given n cities with known distances between each pair. Now, the traveling salesperson problem finds the shortest tour that passes through all the cities exactly once before returning to the starting city. Suppose, for example, it starts at the city A. It need to visit remaining all cities B, C, and D. Finally, it has to reach A again within a shortest path. That is to be called as traveling salesperson problem. So this same problem can be alternatively represented as finding the shortest Hamiltonian circuit in a wide connected graph. This is also to be called as traveling salesperson problem. Right. Now, here you can see what are the possibilities for finding the tours. First, we are writing all possibilities. The first path that is possible is A to B, B to C, C to D, D to A. What is the cost of that path? A to B is 2, and B to C is 3, and C to D is 7, and D to A is 5. Totally, it becomes 17. The other possibilities are represented here, and their costs are represented here. Now, which gives the minimum cost? The first one gives the minimum cost, as well as the last one gives the minimum cost. These two can be taken as the optimal costs. Here we are taking the objective function minimum value we are considering. Earlier I said that may be minimum or maximum or a suitable solution. Here the objective criterion is minimum in case of traveling salesperson problem. Right. Now here you can see one more example of exhaustive search problem, which is nothing but a 0 by 1 knapsack problem. Here, what is knapsack problem? Given a knapsack with a capacity W and a set S consisting of n items. So here you are given a set of n items and a knapsack with a capacity W. Each item I has some weight Wi and a profit value Vi. That may be a benefit value or a profit value. Here the problem is how to pack the knapsack to achieve maximum benefit value of the packed items within the weight limit or within the capacity limit. So that is, whenever I place an object or an item into the knapsack, its benefit value can be gained by us. Right. Now, if I place partial item, partially we will get the benefit. Benefit value can be obtained by us partially. Right. Now, we need to fill the knapsack with the items in such a way that we need to achieve maximum benefit value within the capacity limit. That is, the maximum value should be maximum and the weight should be less than or equal to the total weight of the objects or items placed is less than or equal to the capacity of knapsack. So here this problem is to be called as fractional knapsack or 0/1 knapsack. Suppose if fractions of the items are not allowed, then it is to be called as fractional knapsack. If the fractions of the objects are allowed, then it is to be called as fractional knapsack. If fractions are not allowed, it is to be called as 0/1 knapsack. 0 means that particular item is not selected. If any item value is 0 means that particular item is not selected. If any item value is 1 means that particular item can be selected completely. If any item value lies between 0 and 1 means fraction of the item can be considered. So if fractions are allowed, that is to be called as fractional knapsack. If fractions are not allowed, that is to be called as 0/1 knapsack problem. Now here you can see an example. Here we have taken items. 4 items are given. Each item is having a weight and each item is having a value. And here the capacity is given as 16. Now, what the possibilities of the subsets? I can place first item singly. So whose weight occupied is 2 and whose capacity is 20. And second item singly. Like that I can place, these are the possible subsets that I can place into the knapsack. Now, if you observe this one, here, this crosses the capacity. So that way it is not feasible solution. This also crosses the capacity. This also crosses the capacity of knapsack. This also crosses the capacity of knapsack. All these 4 are not feasible. These are infeasible solutions. Now, out of the remaining subsets, which gives the maximum value, here 80 is the maximum value. 80 maximum value means the set 2, 3. That is item 2 and item 3 gives the maximum value. So we can place item 2 and item 3 into the knapsack to get the maximum value within the weight limit. That weight is 15, which is less than or equal to 16. Right. Next, we are going to see job assignment problem. One more example for exhaustive searching. Here you are given n people who need to be assigned to execute n jobs. 1 person for 1 job. Cij is the cost of that job. Cost of ith person is assigned to the job j. Right? Cost of doing jth job by the ith person. That is to be called as C of ij. Now let us see here. The cost of doing job 1 by person 1 is 9. Job 2 by person 1 is 2. Job 3 by person 1 is 7. Like that. You are given 4 jobs and 4 persons. N jobs are there. N persons are there. Right. Any person can do any job. Right. Now, which is the best assignment of jobs for the persons that we need to find? Suppose, for example, if we assign the jobs in this way, 1, 2, 3, 4. Now, how can I get? For the person 1, first job is assigned, so its cost is 9. For the person 2, second job is assigned, its cost is 4. For the person 3, third job is assigned, whose cost is 1. For the person 4, fourth job is assigned, whose cost is 4. So by adding this, we will get its cost as 18. Now, if I do in this way, if I do the assignment in this way, first person given first job, which is nothing but 9. Second person given second job, which is nothing but 4. Third person given fourth job, which is 8. Fourth person given third job, which is 9. So it becomes 30. Like that, we can write n factorial possibilities. Totally here, n is 4. We can get 4 factorial possibilities. That is 24 possibilities. Out of those 24 possibilities, whose cost is less, that possibility can be selected. So this problem is to be called as job assignment problem, which can be solved using exhaustive searching. So whatever it may be the case, whatever the cases, whatever the examples that we see, traveling salesperson or 0 by 1 knapsack problem or job assignment problem, we are seeing, we are searching for all possible solutions. We are not straight away finding the solution. We are searching for all possible solutions. That is, the exhaustive search method or brute force techniques takes much time complexity in order to find the solutions of these problems. I hope that you all understood this exhaustive search also. Thank you for listening the session.